Let's talk about Pascal's formula. So Pascal's formula says for integers n and r, if r is not equal to 0, it means that the minimum value that r can take is 1, and r is less than equals to n, we have the following relation between the combinations. The combination of r object out of n plus 1 object can be broken down into the combination of r minus 1 object out of n object plus the combination of r object out of the n object. Okay, let us take a look at the short proof. They want to show that n plus 1 factorial divided by r factorial times n plus 1 minus r factorial is equal to n factorial over r minus 1 factorial n minus r plus 1 factorial plus n factorial divided by r factorial n minus r factorial. This is what we try to prove here. We can start from left, go to right, or from right to left. From left-hand side, what do we have? We have n factorial divided by r minus 1 factorial n minus r plus 1 factorial plus n factorial divided by r factorial n minus r factorial. So we want to combine these two fractions. Of course, you can just factor out n factorial and write it outside. 1 divided by r minus 1 factorial n minus r plus 1 factorial plus 1 over r factorial n minus r factorial. Well, to be able to combine these two fractions, you need to have the same denominator or finding the least common denominator. So let's see what we can do, how we can break these down. So this guy is equal to n factorial, and the very first fraction can be written as 1 divided by, here you have r minus 1 factorial, copy this guy down, but break this one into n minus r plus 1 times n minus r factorial plus the second fraction, r factorial. Let's write this as r times r minus 1 factorial and keep this guy as it is, n minus r factorial. Well, what you can do, you can also factor this out and write it in front of the parentheses. You have n factorial divided by r minus 1 factorial. It's repeated in both of these, and also n minus r factorial. And then take the common denominator for whatever is left here. You have 1 divided by n minus r plus 1 plus 1 over r. So this guy becomes n factorial divided by r minus 1 factorial times n minus r factorial, and here if you take the common denominator, r times n minus r plus 1, you're left with r plus n minus r plus 1, which is nothing but n factorial divided by r minus 1 factorial n minus r factorial times, let's write the rest of them down next to this, r times n minus r plus 1. And on the numerator, we can cancel out these two. We get n plus 1 But n plus 1 times n factorial is nothing but n plus 1 factorial. And down here, r times r minus 1 factorial is r factorial. And n minus 1 factorial times n minus r plus 1 is n minus r plus 1 factorial. So as you can see, left-hand side and right-hand side are the same thing. So from left-hand side, and this is right-hand side, so right-hand side reach to the left-hand side. You could start from left-hand side and go to the right-hand side as well. So we just prove this relation between the combination of r out of n plus 1 objects, r minus 1 out of n objects, plus r out of n objects.